Dr. Hartmut Nevin, head of Google's quantum computing efforts, stated that the chip's performance lends credence to the notion that quantum computation occurs in many parallel universes. Unverified reports emerged suggesting NASA's most advanced quantum computer produced results so alarming that operations were immediately halted. What these reports claim it discovered might be beyond anything we're prepared to handle. The system, intended to help us explore the stars, may have revealed something about our future that nobody expected, according to these sources. What happened behind closed doors at NASA and Google's quantum lab has led to a notable lack of public updates in advanced computing. Multiple sources from 2023 and 2024 reported unexpected results that defied known physics. Here's the key point. NASA has not publicly commented on these claims, leaving uncertainty. When a major quantum research effort reduces public output, it raises questions about what might have been found, though no verified information confirms these speculations. Here's what we know. Between November 2023 and July 2024, unverified reports surfaced about NASA's quantum computing project experiencing something unprecedented. TechZone, an obscure outlet, claimed NASA halted operations after their quantum system produced outputs that were, quote, inconsistent with known physical laws. Then TechShepherd, another lesser-known source, suggested the pause wasn't because the system failed, it was because it succeeded too well. These reports alleged the quantum computer generated results so unexpected, so outside normal parameters, that it required immediate assessment. Dr. Hartmut Nevin, head of Google's quantum computing efforts, stated that the chip's performance lends credence to the notion that quantum computation occurs in many parallel universes. Unverified reports emerged suggesting NASA's most advanced quantum computer produced results so alarming that operations were immediately halted. What these reports claim it discovered might be beyond anything we're prepared to handle. The system, intended to help us explore the stars, may have revealed something about our future that nobody expected, according to these sources. What happened behind closed doors at NASA and Google's quantum lab has led to a notable lack of public updates in advanced computing. Multiple sources from 2023 and 2024 reported unexpected results that defied known physics. Here's the key point. NASA has not publicly commented on these claims, leaving uncertainty. When a major quantum research effort reduces public output, it raises questions about what might have been found, though no verified information confirms these speculations. Here's what we know. Between November 2023 and July 2024, unverified reports surfaced about NASA's quantum computing project experiencing something unprecedented. TechZone, an obscure outlet, claimed NASA halted operations after their quantum system produced outputs that were, quote, inconsistent with known physical laws. Then TechShepherd, another lesser-known source, suggested the pause wasn't because the system failed. It was because it succeeded too well. These reports alleged the quantum computer generated results so unexpected, so outside normal parameters, that it required immediate assessment. Here's a thought to consider. What if the reduced activity wasn't because something went wrong? What if it was due to routine recalibration or classified advancements? When a research facility reduces public output after years of transparency, it could indicate internal shifts, not necessarily a cover-up. And when you're dealing with technology that can model complex systems, advancements may be kept confidential for security reasons. According to an unverified TechZone article from November 29th, 2023, sources inside the NASA-Google partnership described something unusual. The quantum system produced outputs that seemed to challenge fundamental laws of causality. These claims suggest data that shouldn't exist. Tech Shepherd's July 2024 report included an unverified detail. 3 senior researchers reportedly requested transfers out of the Quail program within weeks of the alleged incident. According to their article, no explanations were given, no exit interviews, just silence and signed NDAs. This report remains unverified. One anonymous source, claiming to be a quantum engineer familiar with the project, told Uday India that the system had begun generating what they called impossible solutions. Not wrong solutions, not errors, but solutions that worked but shouldn't exist, according to our understanding of physics. Here's what's notable. Online claims suggest that in NASA's internal job postings from late 2023, there was a spike in requests for specialists in quantum anomaly assessment and non-standard output analysis. These claims have not been confirmed via public records and remain speculative. When multiple unverified sources report similar claims, and when online discussions mention researcher transfers or new roles, it raises questions about what might be happening. But no credible evidence supports claims of a groundbreaking discovery requiring an extraordinary response. To understand what NASA's quantum computer might be processing, you need to grasp what these machines do. They don't just calculate faster, they operate using quantum principles. Through quantum superposition, they can analyze millions of possibilities simultaneously. Google's quantum team has demonstrated that their systems can model molecular interactions impossible for classical computers, as seen with the Willow processor. IBM's quantum division is simulating chemical reactions that could revolutionize medicine. These systems can also model complex systems, potentially including societal trends, though no evidence confirms NASA applied them this way. Imagine a computer that can simulate scenarios based on current data, climate patterns, economic systems, technological development, social dynamics. Such simulations are theoretical and unconfirmed in NASA's case. Quantum computers excel at detecting patterns. They can identify cascade effects where small changes lead to significant outcomes. While some speculate NASA's system detected critical tipping points, no evidence supports this. This isn't science fiction. MIT researchers have used quantum systems to predict market trends with high accuracy. Stanford's quantum lab modeled disease spread patterns. If these systems can do that, their potential applications are vast, though unconfirmed in NASA's case. If there's one person who understands the dangers of advanced technology, it's Elon Musk, and his warnings about AI and quantum computing are notable. In interviews, Musk has stated, "The danger of AI is much greater than the danger of nuclear warheads." In a 2023 tech conference, he mentioned the combination of quantum computing and AI as a significant risk. He said, "When AI gains quantum capabilities, we're not just facing a faster intelligence. We're facing something that can see possibilities we can't even imagine." Unverified reports from a private tech summit claim Musk became concerned when discussing quantum AI fusion, allegedly saying, "We're building a crystal ball that might show us futures we can't prevent. This is the man who has access to advanced AI systems through his companies. After unverified reports of NASA quantum incidents, Musk intensified calls for AI regulation, tweeting, "We need to slow down, not speed up," and meeting with senators in late 2023. What Musk understands, quantum computers process information differently. Combined with AI's pattern recognition, they could identify complex trends, though no evidence confirms NASA achieved this. NASA's Quantum Artificial Intelligence Laboratory, or QUAIL, was established in 2013 at the Ames Research Center. It's a joint venture between NASA, Google, and the University Space Research Association. Its goals include optimizing spacecraft trajectories, simulating space weather, and enhancing mission planning. To model space missions, these systems simulate complex variables: gravitational fields, solar radiation, cosmic ray interactions, using quantum mechanical rules. Dr. Eleanor Rhee, a senior researcher at QUAIL, noted that quantum computers designed for astrophysics can model complex systems. History shows accidental discoveries. Penicillin was found while studying bacteria. Cosmic microwave background radiation was discovered while addressing antenna noise. It's possible NASA's quantum computer, while modeling space phenomena, produced unexpected results, though no evidence confirms this. In early 2023, QUAIL published papers on multidimensional optimization in chaotic systems. By April, they explored quantum prediction algorithms for nonlinear dynamics. Then, public output decreased. Researchers Val and Osmanov published a paper proposing quantum computers could detect patterns in complex data. While there's no evidence NASA found extraterrestrial signals, it raises questions about what these systems might detect. In December 2023, Uday, India, published an unverified claim. The quantum system produced outputs that seemed to communicate in patterns scientists couldn't decode, described as speaking a language that violates causality. Quantum mechanics already challenges common sense. Particles exist in multiple states until observed. Information travels instantly across entangled particles. Time can flow backward at the quantum level. If classical physics is like reading a book, quantum physics is like reading every possible version simultaneously. Unverified sources reported the quantum computer generated patterns that were consistent but hard to explain. One alleged researcher compared it to finding a solution to an unsolvable equation. Some speculated the system tapped into quantum foam or parallel quantum states. These ideas are debated in physics journals, but lack evidence in NASA's case. What's telling is the reported human response. Scientists don't typically request transfers without reason. Facilities don't create anomaly assessment roles for routine errors, though no evidence confirms NASA did this. When professionals encounter something unusual, it merits attention, but no verified data supports these claims. The most grounded explanation is the most straightforward. NASA's quantum computer may have produced complex results requiring further study, not necessarily a terrifying discovery. Quantum computers excel at modeling complex systems. DeepMind's AlphaFold predicted protein structures. D-Wave systems optimize supply chains. Applying this to societal systems is theoretical and unconfirmed. Environmental scientists have identified the 2070s as a potential convergence point for climate challenges. But no evidence suggests NASA's quantum computer modeled this. These systems map cascade effects, but no confirmed data links NASA's work to such predictions. As of July 2025, Google's Willow processor has set quantum computing records, as confirmed by Google. IBM is advancing toward 100,000 qubits. China has made progress in quantum communications. NASA's Quail has reduced public output since April 2023, with no recent papers or presentations confirmed. The National Quantum Initiative budget increased in 2024, and the Pentagon expanded quantum research per public records. Congress held hearings on quantum security, and the NSA established quantum threat assessment teams. Why invest in a technology if it hit a dead end? The funding suggests ongoing progress, not failure. Tech insiders report corporations like Microsoft, Amazon, and Meta are exploring quantum applications as confirmed by industry trends. If nothing significant happened at NASA, why the increased activity? It's likely routine advancement, not a hidden discovery. This investigation continues. Unverified reports suggest NASA's quantum computer generated unusual results. Research output decreased, and oversight intensified. This could indicate routine progress or classified work, not necessarily a groundbreaking find. Either NASA's quantum computer produced complex results, is undergoing internal review, or is part of classified advancements. Each possibility is significant, but lacks public confirmation. If quantum computers can model complex systems, that capability shapes research, planning, and policy. The fact that information is emerging suggests ongoing developments. Whether through public research or global advancements, more details will surface. The question is, how will we use this knowledge? Some advancements drive progress. Others require careful management. NASA's reduced output suggests they're assessing their findings. For technical details, quantum computing uses qubits in superposition, simultaneously 0 and 1. Through entanglement, qubits correlate across distances, enabling powerful parallel processing. QALE, established in 2013 at NASA's Ames Research Center, uses D-Wave quantum annealing systems and Google's gate-based processors. Quantum computers face challenges. Decoherence and noise introduce errors. Google's surface code improvements, used in Willow, have enhanced reliability, as confirmed in 2024. Major players include IBM, Condor and Flamingo processors, Google, Willow, D-Wave, annealing, and Rigetti and IonQ. Post-quantum cryptography, like Crystal's Kyber and Crystal's dilithium, resists quantum attacks, as standardized by NIST. Quantum computing is advancing drug discovery, materials science, financial modeling, AI, weather prediction, and cryptography. What started as unverified reports of a shutdown reveals a complex field. This isn't about one computer going offline. It's about a technological frontier. Throughout history, discoveries bring consequences. The atomic age introduced energy and threats. The internet connected and divided us. Quantum computing offers immense potential, but its applications must be managed. Whether NASA's work involves routine advancements or classified research, the technology is real. This story is ongoing. As quantum systems advance, we'll gain clarity on their capabilities. When research output slows and investment grows, it signals progress, not failure. History shows change arrives quietly before it reshapes the world. NASA's quantum work continues, and its impact is yet to be fully understood.